This effect, called time dilation, is not science fiction, it is real. Proven by Einstein's equations and observed in experiments near massive objects like Earth, but around a black hole, this warping of time becomes extreme. A journey toward the event horizon is not just a journey through space, it is a journey into the future. Think about that. A black hole doesn't just trap matter, it traps moments, memories, even time itself. It is the ultimate reminder that the universe is far stranger than we can ever imagine. For in the shadow of a black hole, space can fold, time can twist, and reality itself begins to unravel. Not all black holes are the same, just as stars come in different sizes and lifespans. Black holes to have categories each more mysterious than the last. From the remnants of dying stars to monsters that anchor entire galaxies, black holes exist on scales beyond imagination. These are the most common type, formed when massive stars die in supernova explosions. They usually have masses ranging from a few times the mass of our Sun to about 20 times more. Though small compared to other black holes, their gravity is still extreme, compressing entire suns into regions smaller than a city. These stellar mass black holes can roam the galaxy silently, sometimes paired with companion stars. When that happens, they feed on their neighbor's gas, creating brilliant X-ray signals that allow astronomers to detect them. For decades, scientists wondered if there could be black holes larger than stellar ones, but smaller than the supermassive giants at galaxy centers. The answer seems to be yes. Intermediate black holes. With masses ranging from hundreds to thousands of suns, they are rare and hard to detect. Their origin is still a mystery. Some believe they form when smaller black holes merge together. Others think they may be relics from the early universe. If confirmed, they could be the missing link between stellar and supermassive black holes. These are the true giants, the monsters at the hearts of galaxies. Their masses are millions, sometimes billions, of times greater than our Sun. The one at the center of our own Milky Way is called Sagittarius A*, weighing around 4 million suns. And yet, despite their unimaginable size, they are silent engines that shape galaxies themselves. They control star formation, influence cosmic structures, and may even decide the fate of entire galaxies. Without supermassive black holes, galaxies as we know them may not even exist. Perhaps the strangest of all are the black holes that may have formed not from stars, but from the birth of the universe itself. These are called primordial black holes, believed to have formed seconds after the Big Bang, when extreme density fluctuations could have collapsed tiny regions of space into miniature black holes. Some might be as small as an atom, yet with the mass of a mountain. If they exist, they could hold clues about the earliest moments of creation. At the very heart of almost every galaxy, including our own Milky Way, lies a supermassive black hole. These giants are unlike anything else in the cosmos. They can be millions, even billions of times heavier than our Sun, yet all of that mass is concentrated in a region smaller than our solar system. Their sheer size and power make them not just residents of galaxies, they are their architects. Take our galaxy for example. At its center, 26,000 light-years away, lies Sagittarius A*. It is about 4 million times the mass of the Sun, a silent engine sitting in the dark. For centuries, we had no proof it was there until astronomers tracked the orbits of nearby stars. These stars whipped around an invisible point, moving at speeds so great that only a black hole of immense size could explain their motion. That was when we realized, we live in the shadow of a cosmic giant. But supermassive black holes are not just passive monsters, they shape galaxies themselves. Their gravity influences the distribution of stars, while their powerful jet streams of energy and particles shot out at nearly the speed of light, can regulate star formation. In some galaxies, these jets stretch thousands of light-years into space, altering the very structure of the galaxy and the space around it. Imagine this, a black hole that can both feed on stars and gas, while also controlling how many new stars are born. Without them, galaxies might collapse under their own chaos. With them, galaxies take form, stabilize, and evolve. In this way, black holes are not just destroyers, they are also creators, playing a hidden but vital role in the universe's grand design. And then, there are the truly monstrous ones. Some supermassive black holes, found in distant quasars, are billions of times more massive than our Sun. They blaze with energy as they devour surrounding matter, shining brighter than entire galaxies. To gaze at them is to look into the most powerful engines the universe has ever built. Supermassive black holes are not just objects of fear, they are the quiet sculptors of the cosmos. They remind us that in the darkest places of the universe, life, light, and creation are all shaped by forces we can barely comprehend. At the core of every black hole lies the most haunting enigma in all of science, the singularity. This is the point where all the mass of the black hole collapses into infinite density, a place where gravity becomes endlessly strong and space and time curve into oblivion. On paper, the singularity is the ultimate dead end, a point where the laws of physics, as we know them, simply break. Einstein's general theory of relativity, which describes how gravity works, predicts that singularities must exist inside black holes. According to relativity, space-time is bent so severely near a black hole that at the center, it collapses entirely into this infinitely dense point. But here's the problem. Relativity works beautifully for stars, planets, and galaxies, but it does not play well with the tiny, quantum world of atoms and particles. This is where quantum mechanics comes in, the science of the very small. Quantum theory explains the behavior of subatomic particles, the uncertainty that exists at the smallest scales, and the strange reality of probability. But when we try to apply quantum mechanics to a singularity, everything falls apart. Relativity says infinite density. Quantum mechanics says impossible. It's as if the universe has hidden its most powerful secrets behind a locked door, and the key is missing. Physicists call this the greatest unsolved problem of modern science. The need for a theory of everything, a single framework that unites relativity and quantum mechanics. Without it, the singularity remains a place of paradox, something that should not exist, yet does. Some scientists believe that singularities may not even be real, that quantum effects at the smallest scales somehow smear out the infinite density, replacing it with something else, perhaps a region of exotic matter, or even a bridge to another universe. Others suggest that black holes could act as cosmic laboratories, teaching us how gravity truly behaves when pushed to its extreme. This clash is not just a puzzle, it is a challenge to our very understanding of reality. Black holes stand at the crossroads of the largest and smallest forces in the universe. They whisper to us that the rules we know are incomplete, that somewhere in the shadows lies a deeper truth waiting to be discovered. To peer into a black hole is to stare into the place where our science fails, and yet, perhaps, where the next great revolution in human knowledge will begin. For centuries, black holes have not only challenged scientists, they have captured the imagination of dreamers, storytellers, and philosophers. Because if these cosmic giants can bend light, twist time, and swallow stars, then perhaps they can also open doors to realities we can barely imagine. One of the most fascinating ideas is the concept of wormholes. In Einstein's equations, a black hole may not just collapse space-time, it may connect it. A wormhole would be like a tunnel linking to distant regions of the universe, or perhaps even to entirely different universes. If such pathways exist, they could shorten journeys across galaxies, turning millions of years of travel into seconds. Science fiction has embraced this idea, from interstellar voyages to alternate dimensions. But the truth, we don't know if wormholes are stable, or even real. Some theories say they could exist only for fractions of a second before collapsing. Others suggest exotic matter might be needed to keep them open. Then there's time travel. Near a black hole, time itself flows differently. If you hovered close to the event horizon, just for a few hours, you could return to find that thousands of and millions of years had passed in the outside universe. In a sense, black holes already allow travel into the future. The question is, could they also let us travel into the past? Most scientists doubt it, because time loops create paradoxes that break the rules of cause and effect. But still, the idea lingers. Could the key to time itself lie in the heart of these cosmic mysteries? And perhaps the boldest thought of all, alternate universes. Some physicists speculate that what falls into a black hole may not simply be destroyed. Instead, it could be transported beyond our universe, into another. Each black hole could be a seed, birthing a new cosmos hidden from our own. If that is true, then our universe too may have been born from a black hole in another, larger reality. These ideas remain unproven, yet they remind us of something deeply human, our hunger to imagine, to dream beyond what we know. Black holes may be the universe's greatest mysteries, but they are also mirrors of our own curiosity. They force us to ask not only what is real, but what might be possible. Because in the silence of the cosmos, in the darkness of a black hole, we see both the limits of science and the boundless reach of imagination. Imagine drifting through the silence of space, your ship caught in the grip of a black hole. At first, nothing feels unusual. You are floating through the stars, watching galaxies glitter in the distance. But slowly, the pull grows stronger. Invisible, unstoppable, it draws you closer and closer toward the dark center. And then, you cross the point of no return. The first thing you would notice is light itself bending. The stars behind you would stretch and warp, their colors shifting, as if the very sky was being painted across the horizon. Time would begin to twist. To you, moments would pass normally, but to the outside universe, your fall would look slower and slower, as if you were frozen on the edge of eternity. As you move closer, you would encounter one of the strangest, most terrifying effects of a black hole. Spaghetti. The gravity near a black hole is so extreme that it pulls on different parts of your body with different strengths. Your feet would be dragged faster than your head, your body stretched thinner and thinner, like a strand of spaghetti, until you are torn apart at the atomic level. To you, it would happen instantly. To the universe outside, your final moments would linger forever, frozen on the horizon. And yet, what lies beyond this? That is the mystery. Science cannot say for certain. Some theories suggest you would be crushed into the singularity, lost forever, in infinite density. Others hint that your information, your very being, might not be destroyed, but somehow encoded on the event horizon itself. in what physicists call the black hole information paradox. There is also the tantalizing possibility that falling into a black hole might not mean destruction at all. Perhaps, beyond the horizon, lies something else, another universe, another reality, or even another beginning. To fall into a black hole might not be an end, but a passage, though one from which no traveler has ever returned. To imagine such a journey is to confront both our deepest fears and our wildest hopes. For in the heart of a black hole lies the greatest unknown. It is the ultimate one-way trip into silence, into mystery, into the very edge of existence itself. For most of human history, black holes were only ideas, mathematical predictions drawn from Einstein's equations. They were ghosts in the universe, invisible and unreachable. But in just the past few decades, humanity has begun to shine light into this darkness. The age of black hole discovery has truly begun. In 2015, scientists using the LIGO Observatory detected something extraordinary: gravitational waves. These are ripples in space-time itself, created when two black holes collide and merge into one. The signal traveled across the cosmos for over 1 billion years before reaching Earth. Tiny vibrations that stretched and squeezed our planet by less than the width of an atom. Yet that was enough to prove that black holes are real, and that their violent dances echo across the fabric of the universe. Gravitational waves opened an entirely new way of observing the cosmos, not with light, but with the trembling of space-time itself. Then, in 2019, came another milestone. The world saw the first ever image of a black hole, and this is only the beginning. Future telescopes will take sharper images, perhaps even movies, of matter spiraling into the abyss. New detectors will hear more gravitational waves from black hole mergers, mapping the hidden population of black holes across the universe. Some scientists are even exploring the possibility that black holes could explain dark matter, the invisible substance that makes up most of the cosmos. Perhaps one day, we will learn what truly happens beyond the event horizon. Perhaps we will discover whether black holes destroy information or guard the secrets of new universes. Each discovery pushes us closer to the answers, and yet, with every answer, more questions arise. The study of black holes is not just about science, it is about humanity's endless desire to know, to reach, to understand. They are cosmic mysteries, yes, but they are also milestones in our journey. With each step forward, black holes remind us that even in the darkest places of the universe, there are truths waiting to be revealed. Black holes are among the most terrifying and beautiful mysteries of the universe. They are born from the deaths of stars. They shape galaxies, they bend light, and they twist time. They defy our understanding, standing as silent reminders that there are still places in the universe where human knowledge has not yet reached. And yet, maybe that is what makes them so powerful. In their darkness, we find questions about creation itself. In their silence, we hear the echoes of the universe's deepest truths. And in their mystery, we see a reflection of ourselves, curious, fragile, but endlessly determined to search for meaning. When we look at a black hole, we are not just studying an object in the sky. We are confronting the limits of reality. We are staring into the place where science meets wonder, where fear meets hope, and where destruction may hide creation. These invisible giants are not only the end of stars, they may also hold the beginnings of new worlds, new universes, perhaps even the key to why anything exists at all. Our journey tonight has taken us from the fiery death of massive stars to the heart of galaxies, from the warping of space and time to the possibility of wormholes and alternate universes. And still, the story is not finished. Because every black hole we find, every signal we detect, every image we capture, brings us closer to unlocking the secrets of the cosmos. And maybe, just maybe, those secrets will tell us something not only about the universe, but about ourselves. For in the vastness of space, in the silence of the stars, black holes remind us of both our smallness and our greatness. We are tiny in the face of infinity, but we are also the only creatures we know of who dare to ask these questions, who dare to dream beyond the horizon. Thank you for joining us on this journey into the science and the mystery of black holes. If this story moved you, inspired you, or made you wonder, don't let the journey end here. Subscribe to our channel and ring the bell icon so together we can continue exploring the wonders of the universe. From the fragile blue dot we call home to the darkest giants hidden among the stars, the universe is full of stories waiting to be told. And this is just the beginning. There are places in the universe where the rules of reality itself collapse. Places so powerful, so mysterious, that even light, the fastest traveler we know, cannot escape their pull. These are black holes. Imagine a star so massive that when it dies, it doesn't just fade away, it collapses in on itself, crushing everything it ever was into a single, invisible point. A point with infinite gravity, a place where time slows to a crawl, a region where space itself bends, stretches, and finally breaks. For centuries, humanity has looked up at the night sky and wondered about the stars. But black holes, they are not just stars. They are cosmic monsters, silent, invisible predators that wait patiently in the darkness. They swallow planets, stars, and even entire solar systems without a sound. They are the edge of everything we know, and perhaps, the gateway to everything we don't. The thought alone is chilling. What lies beyond the event horizon, the boundary where no return is possible? Could it be a portal to another universe? A tunnel through space and time? Or is it simply the end? Black holes defy our logic, our imagination, even our understanding of physics. They are where Einstein's theory of relativity and the strange laws of quantum mechanics collide in a battle that science still struggles to explain. To study them is to stare into the abyss of existence itself. And yet, we cannot look away. Because within these mysterious giants lies not just destruction, but answers. Answers to how galaxies are born, how time and space intertwine, and maybe even to the ultimate question of what lies beyond life and death. Tonight, we will journey into the heart of darkness. We will uncover the terrifying beauty and the haunting science behind black holes. From their violent birth in exploding stars, to the unimaginable power of supermassive black holes at the center of galaxies. We will face the unknown, together. And in the process, we may discover that the darkest objects in the universe may also hold the brightest secrets of creation itself. Before we dive deep into this journey across space and time, make sure you subscribe to our channel. Hit the bell icon so you never miss our documentaries about the mysteries of the universe. Together we'll explore the cosmos, uncover secrets science has only begun to reveal, and bring the wonders of space into your home. Welcome to our documentary, The Science Behind Black Holes. In the next hour, we will uncover the secrets of these invisible giants. We'll travel from the death of massive stars to the edge of the event horizon. We'll explore how black holes bend space, slow time, and reshape galaxies. We'll dive into the greatest questions scientists still struggle to answer. What happens inside a black hole? Could they be portals to other worlds? And what do black holes teach us about the very fabric of reality? Every black hole begins its story with a star. Not just any star, but a star so massive, so powerful, that its very existence is a battle between creation and destruction. For millions, even billions of years, a star shines by fusing hydrogen into helium at its core. This nuclear fire pushes outward with immense energy, while gravity tries to crush the star inward. The two forces balance perfectly, and the star lives in harmony. But nothing in the universe lasts forever. Slowly, the fuel at the star's heart begins to run out. When the core can no longer resist gravity, the delicate balance shatters. The star begins to collapse in on itself. Temperatures soar, elements heavier than iron are created, and in a final desperate act, the star explodes outward in one of the most violent events in the universe, a supernova. A supernova is not just destruction, it is also creation. It scatters elements like carbon, oxygen, and iron into space, seeding the birth of new stars, new planets, and even the building blocks of life itself. Every atom in your body was forged in such a cosmic explosion, but for the massive star that dies this way, its own fate is far more mysterious. When the explosion is over, the outer layers are blown into the galaxy, but the core remains behind. For smaller stars, this core may become a neutron star, a dense, city-sized object, made almost entirely of neutrons. But if the star is massive enough, 10, 20, or even more times the mass of our sun, gravity wins the final battle. The core collapses completely, crushing matter down to a single, unimaginable point, a singularity. This singularity is where density becomes infinite, where the laws of physics as we know them no longer apply. Around it forms the event horizon, the invisible boundary from which nothing, not even light, can escape, and thus, a black hole is born. What was once a shining beacon in the universe has now become a silent, invisible predator. A star that once gave life to worlds now marks a place where time and space themselves are broken. It is one of the most haunting transformations in the cosmos, from light into darkness. The most mysterious feature of any black hole is its event horizon, the invisible boundary that marks the point of no return. It is not a solid surface, not a wall, not even something you could touch. Instead, it is a horizon in space where gravity becomes so strong that escape is impossible. Imagine standing near a cliff. Step back, and you are safe. Step too close, and you fall. The event horizon is like that cliff, except instead of falling into an abyss of rock and earth, you fall into the very collapse of space and time. At first glance, space outside a black hole seems ordinary. A star, a planet, even light can orbit around it. But the closer you drift, the stranger reality becomes. Light begins to bend, time begins to slow. To an observer watching from far away, you would appear to move slower and slower, as if caught in a film, stuck on pause. The event horizon is the ultimate cosmic trap. Once anything crosses it, whether it's a star, a planet, a beam of light, or even you, there is no coming back. From the outside, we can never see what happens beyond this veil. Information itself seems to vanish, swallowed into the darkness. But what truly lies inside, that is the greatest question of all. Does matter collapse into the singularity, crushed into an infinite point? Or do black holes hide doorways, gateways to other regions of the universe, or even other universes entirely? Science does not yet have the answers. The event horizon stands as a border between the known and the unknown, a mystery that challenges the very limits of human understanding. It is haunting to think, every black hole has this invisible surface, silently waiting, and if you were to fall past it, you would never know the exact moment you crossed the line. For you, time would continue. But to the universe watching from the outside, you would be gone forever. The event horizon is not just a boundary in space, it is the edge of reality itself. To understand the true power of a black hole, we must first understand the fabric of the universe itself, space and time. For centuries, people thought of space as empty, and time as constant, ticking forward like the hands of a perfect clock. But Albert Einstein changed everything. Einstein revealed that space and time are not separate, they are woven together into one grand fabric called space-time, and this fabric is not rigid. It bends, stretches, and curves whenever mass and energy are present. Imagine placing a heavy ball on a rubber sheet. The sheet curves downward, and smaller objects roll toward it. This is how gravity works. Planets orbit stars, not because of an invisible force pulling them, but because the stars warp the fabric of space-time, guiding the planets along curved paths. Now imagine that star collapsing into a black hole. The rubber sheet doesn't just curve, it tears downward into a pit so steep, nothing can climb out. This is how a black hole bends space-time itself. It is not just an object in the universe, it is a hole in the very geometry of reality. But the strangeness does not end there. Near a black hole, time itself begins to distort. The closer you move to the event horizon, the slower time flows for you compared to the rest of the universe. To someone watching from far away, you would appear frozen, as if eternity itself had wrapped around you. But to you, time would feel normal, seconds passing as usual, while the outside universe races ahead by thousands, even millions of years.